these are some of the issues we discussed with the California Public Utility Commission years ago. What's the possibility of a cable becoming overheated, igniting itself, dropping to the ground, and creating a wildfire? Good question. Well, we have protective devices on those lines, reclosers, breakers, fuses, and we have not only protective devices, we have backup protective devices that remove the circuit in case of an overcurrent or a fault. We know that IEEE 121.733 standard for tree wiring message boarded spacer cable requires cross-link to have a higher temp rating for covered conductor. So these, again, are higher temp ratings. And lastly, we've never had a recorded incident of a protective device or a backup device protection failing to operate and igniting a covered conductor. So what's the possibility of a passing wildfire igniting the cable? Another good one. Well, wildfires usually pass by pretty darn quickly, especially since they're quite often wind-related events, leaving the covered conductor, a cable, unharmed. If that wildfire is static, if it's motionless, if there are no winds, it's just sitting underneath the power line and cooking away at 2,000 degrees Fahrenheit, well, probably everything is going to be burned, not just the cable, but all the surroundings. And again, as we said before, any and all cables might burn, whether it's HDPE, XLPE, or flame retardant mixtures. Lastly, we have no recorded incidents to date of a wildfire igniting a covered conductor. Here is a case in the Great Smoky Mountains National Park. We had a 15 kV line to an antenna site up on the top of the mountain. The U.S. Forest Service set a control burn. That unfortunately got out of control, started a wildfire for 3 days. That wildfire was extinguished with rain. I went up. I was the engineer that did this inspection. We had a little bit of charring on the poles. It went up in a bucket. There was no damage to the cables. There was no damage to the hardware. We cleaned it up, re-energized it, and that was one data point that we did not have a wildfire igniting our covered conductors. Here's another one called the Great Gatlinburg fire. Entire city block burned directly below a double circuit spacer cable. You can see a good part of the city was burned to the ground. These lines, for some reason, right next to the burning, were not damaged. And the only conclusion I can tell you, great, we didn't suffer any damage from a passing wildfire. Reality is probably that the wind was blowing into the screen here. Did an inspection, everything was fine. So another data point, we survived. How about, can a covered conductor jacket ignite and carry the flame to another area? This is what I call the Mission Impossible scenario. You light a fuse and it's going off and it's going to create a wildfire in another area. Don't see how this could happen if a flame was high enough and remains long enough, 2,000 degrees at 40-foot elevation. It's probably a good bet that everything on the ground is already ignited, not only already ignited, but already charcoal. So there's no recorded evidence that this has ever happened in 72 years of experience and 500,000 miles of covered conductor installed, but still worth asking the question. So flammability issues for covered conductor. FR cable is not yet used. Jury's still out. I imagine it's coming. Benefits are still under consideration. Cable becoming overheated and igniting itself, not likely, and we've never had a recorded incident. Passing wildfire, igniting the cable, certainly possible, but inevitable in a static fire, regardless of what the cable is used. Once we have 1,900 degrees at 40-foot height, we've got burnt stuff on the ground. Covered conductor jacket igniting and carrying a flame to another area, not likely, never happened. Don't see it happening. We wanted to talk a little bit about what our colleagues at Southern California Edison did. And again, they did an unbelievable amount of testing, and all of this testing is available open source on the IEEE. They did an absolutely brilliant job. I'm showing the lab testing. They had outdoor testing that was also published. So what they did is they wanted to see, what's going to happen. So they tied all three phases to a wetted tree branch, and you can see that tree branch on the side there. And they shorted the three-phase conductors to each other and to the tree branch, and they tied them on there pretty darn tight with plastic ties. They energized. It was 15 kV cable. They energized it at 3x, 35 kV. They ran that test for 8 hours, which they said was typical of a trouble crew's response time in mountainous areas. Stopped the test, no burning or damage at all, no damage of any marks on the surface. We did a similar test at Hendrix, lasted 1 year without a short circuit. Same, but we didn't test it for 8 hours, we tested it for a year. Those results are also available in the IEEE. If you can't find it, send me an email. I'll send you those papers. SCE, Southern California Edison, said it demonstrates that covered conductor will not cause ignition for tree or ground contact, even for an extended period of contact. Then they went on to test on the infamous Mylar balloons, and they did 2 test setups. One balloon was phase the ground, and the other test was with the balloon between the phase. So phase the ground and phase the phase. They ran these tests for 2 hours each. They did all kinds of monitoring, PD, thermography, and some other complicated stuff. After 2 hours, they disconnected it, and there was no flashover, no current, or evidence of burning or tracking. And they said it demonstrates that Mylar balloons will not fault when trapped on the covered conductor lines. And when we're doing this testing for 2 hours, we didn't really know what to expect. I knew what to expect, but nobody else knew what to expect. I mean, this is pretty hairy. You got a real hardcore short circuit between the phase and ground with a metal object. And one of the technicians said, after an hour and a half, hour 40, he said, relax. This was bare wire. It would have exploded violently within 60, 90 seconds. If we're here an hour, hour and a half, we still don't have any current, we still don't have any heat, this thing isn't going to blow. So similar configuration with Mylar balloons and bare wire lines will result not only in a flashover, but a massive flashover and a fireball with it. So solve your Mylar balloon problems. So how effective is covered conductor in preventing wildfire ignition? Covered conductor has been used for wildfire mitigation since the 90s. Again, we started in Australia after the Marysville fires of the early 90s, and we're working with them ever since. Later on, the USA, and now obviously Canada as well. We don't yet have statistics how many wildfires were not started as a result of covered conductor being used. I'd have to talk to a statistician about that one. We don't know how to figure that out, even though we have people telling us what the effectiveness of that. I guess they need numbers, right? Again, we looked at what Southern California Edison said when they did their studies and the mitigation to cost ratio, that the covered conductor option is the most viable mitigation to cost ratio and the most effective spending of your dollars when you're working towards system hardening with respect to wildfire mitigation. SDGE has not conducted studies to measure the effectiveness of covered conductor. However, number one, they estimate it to be 70% effective. Again, the new estimate from SCE, not 60%, 70%. I would say it's a heck of a lot more effective than that, but we'll go with their numbers. Assuming it will be equally effective as bare conductor hardening at preventing equipment failures, and better than bare conductor hardening at preventing foreign objects in line contacts. Another thing that SDG&E said, which I found really important from an operations standpoint. Again, we have all these things we're doing, monitoring and pole change outs and cross arm change outs, and then we have PSPS, if it's dry and it's high winds, we're just going to shut the power off and throw the whole economy into standstill until the winds die down. But SDG&E said, in addition to its wildfire mitigation benefits, covered conductor has some PSPS benefits as well, raising the threshold for PSPS to higher wind speeds than bare conductor hardening. So that would be a massive benefit if I was a ratepayer or a consumer or just a person trying to run my home or my business and not have the lights go out every time it's dry and the wind picks up. Food for thought. Anyway, this is from SDG&E. So in summary, power lines are an inevitable source of risk for wildfire ignition. Mitigation tools and techniques are available both for bare wire, underground, and covered conductor systems. A covered conductor is a viable and cost-effective tool to combat this phenomena. And as we've seen recently with the news this year, last year, the year before, this problem is not going away anytime soon, unfortunately. So, yeah, we will be looking forward to your questions, and I will send you back over to our moderator. Thank you for tuning in.